Hi everyone, today I'm going to talk with Ram Kumar, core contributor at OpenLedger, and we're going to talk about specialized AI on chain and why the mess is wrong right now. So this is really a super exciting conversation because I really try to go into technical details. And of course it's still general enough so that non-technical people understand it as well, but it's a really engaging and cool discussion asking some more critical questions as well so that I personally really get a real understanding of what they're building and what problems they're solving. And personally, I learned a lot, I really liked it, so I'm pretty sure you will enjoy the conversation as well.
WaveAct, the web-free software company that understands what you want.
Uh, we got ChatGPT, Cloud, and all these general purpose models out there. And of course, everyone knows about them, everyone is using them, at least it seems like that. And while everyone is using these general purpose models, you guys are actually focusing on specialized models, right? So could you put us through like why you think this is the actual future and not like this big uh, all-in-one model?
Yeah, just for clarity, we use larger language models and make them specialized. What we believe, LLMs will continue to exist. There'll be more models that will come in. They will have much more knowledge, but all of this will be like very general knowledge, right? Because that's what they're intended to be. Like how Google search is. Google search is a global search. It has general knowledge about the world. Whatever that you can find on the internet is on Google. But we also use, LinkedIn to connect with professionals. Right? You search about a job on LinkedIn, and then you would probably search for food on Uber Eats, right? You would search for a particular item that you want to buy on Amazon. So it's very specialized driven, very niche searches that evolved from what is Google search, right? So that's how larger language models will be. Larger language models are very generic. It's for the generic day-to-day use. But for specialized models, very unique use cases, you need to have specialized, kind of data sets being given to that. Because let's say someone wants to build a healthcare model, which is very specific to know more about general medicine. You can't have a general knowledge model be used for that, right? It has to be trained on medical based data sets. It has to have a knowledge about how a human body itself works. Only then this model is useful to provide solutions for any kind of ailment, right? Very similarly, if someone wants to build a model or an app for like finance, right? An AI app that's going to let you like basically guide you to trade. It's going to be a co-pilot for you to trade. It needs to understand finance as good as a trader, a hedge fund manager or something like that, right? It has to have the knowledge about trading. A general knowledge, not general model will have the knowledge for that. It's going to have some understanding of it, but it's very basic, right? It'll have how a human kind of understands by looking at blogs and websites and stuff like that. It's not going to have an expert knowledge how a trader who has an experience of 10 years in trading would have. So that's a specialized model. It'll have much more deeper understanding about a particular subject. And it's very natural for technology to be, first generalized, to have a very generic high level knowledge. And then humans us go ahead and build much more specific need based tech. And that's how AI will evolve as well, where we've now started with general knowledge, where people are getting to get familiar with AI. And then we would start using AI in our own day-to-day use cases, right? If you take a look at models that are used in autonomous vehicles, these are vision models, but are specially trained for that particular subject, right? The vision models that are also trained for, let's say, robots to do a some particular work, like figure and all that. There are vision models that are, doing more on the domestic-based robotics and stuff like that. So every model is specialized to its own need. So that's how, our day-to-day life will be solved by AI. People will start implementing AI in all the interactions that we have, and you need models specific for those interactions. And we've seen that already happen in the last 2 years, right? Once ChatGPT was announced, people started using ChatGPT. Then they start to experiment to build models which are specialized. Bloomberg launched Bloomberg GPT. It's one of the most special, models out there, which has knowledge about finance. It's much better than ChatGPT in most of the cases. So that's our thesis, and that's what we see happening in the world as well. Hugging Face provides solutions where people can contribute data and build models, but none of them get rewarded as part of the process, right? It's an open source solution. Open source is great, but it's not a long-term viable process. You need to enable monetization in open source, right? People need to be benefited as part of the process. That's what OpenLedger is trying to bring here. We want to make sure that people who are contributing data sets, who are enabling these models to be built, get rewarded as part of the process. Only then you will have a continuous flow of data coming in. Only then you will have a better quality of data sets that will be coming in. And that is what we're looking to achieve here. And we've seen that happen with most of the cases during our testnet. We have close to about 1 million people contributing data sets for that. We did an experiment where language-based model was needed to be built. Hugging Face, tried to do that by collecting language-based data sets. It took them about 3 months to get about 50,000 participants. We got close to about 300,000 plus participants in just about 2 weeks' time, right? That's what happens when you monetize and you reward people, right? When you then there's incentivization, people will go forward and execute something because everyone needs to feel that if they're providing something, they need to be benefited as part of the process, right? So that's the simple core thesis to enable people to trust and work together on a platform and get rewarded as part of the process. That's what OpenLedger is looking to solve here.
Okay, I got a couple of questions here. The first one, let's imagine we have two companies, right?
Yeah.
One is building a general purpose and one is building a specialized model. Um, let's say they both have the same specialized data set.
Hmm.
Like how, like from a data perspective itself, the data would be the same, right? The only difference is that the general purpose model also has other knowledge that is not related to that specialized task. Like how,
Not okay.
yeah.
Yeah. Sorry, go ahead. Not exactly right. So, for example, um, usually a model which is built for math will probably have most of the theorems and understanding. Like a general model will have that knowledge, right? But let's say you want to build a special model for math, it's much more granular, right? It's much more deeper into each and every subject. So it can solve a math problem, a much more complex math problem, quicker and accurately than a general model, right? Because it's just given more data sets. Like think of this, right? To put in a very simple terms, think of an undergrad or a high school kid to be like a general model, which has like a generic knowledge of the world, and then a PhD student to be like a specialized model. So they just have a better knowledge on the subject. Everyone like the subject is known, people can understand the subject, but a PhD student will have a better understanding and much more faster response and a much more accurate response. That's how specialized models work, and that's how they compare to like general models. And there are certain use cases where the data set itself is not available on the general model. Like for example, we have a team that we're working with that was building like an X-ray model, a model that is trained on X-rays across the globe, right? This is across races, across various diseases and stuff like that. This model identifies and understands X-ray based details much better and has much clarity than a general model. If we upload an X-ray to ChatGPT, yes, it will kind of understand it. It will be able to tell you, but it's not going to give anything accurate. It's not going to give you answers at depth of what a specialized model will do. So in that case, these data sets are not available at all in general model. Only in the specialized X-ray model, you have X-ray based data sets. So it's more case to case. Certain data sets are there in general models, other data sets are only available in specialized models. It could be very case to case.
But like again to the base assumption, right? Like let's say both companies have access to the same data. Like really
Mhm,
the deep specialized data. So
mhm,
why would a specialized model that has less knowledge in general,
mhm,
but the same
mhm.
specialized knowledge as the general purpose model with that specialized knowledge, why would that be better?
In that case, I'm not sure if that's gonna be like a usual. way people build models, right? It doesn't happen, but let's say hypothetically this happens. General models have those specialized data sets. General model is good enough for that. Only way where they would might choose for a specialized model is if this model is, lesser in terms of model size, and you don't need to have a large hosting cost and stuff like that. Apart from that, they would choose like a general model. But most of the cases, which is in reality, general models do not have specialized data sets which are very unique. That's usually is with specialized. That's why they call specialized model. You take something and you specialize it because that data is not there in the general model.
Okay, so the actual reason for specialized models, aside from hosting costs and so on, of course, is the organizational constraint, right? That you don't share highly specialized data with a general purpose company like OpenAI. So that's
Yeah.
actually because, yeah. Okay, cool. You also mentioned already your proof of attribution algorithm consensus protocol, or whatever you want to call it, right? Could you go a little bit deeper on the technical aspect, like how does this actually work? Like, let's say I do have data that I want to share with your blockchain, right, with your infrastructure. How does that work from A to C?
Yeah. So to just go back to basics, right? In any AI model that's being built, like let's say we use ChatGPT, there is OpenAI, which is the model that is running behind that. Think of that to be like a brain that powers this application. So in that model, people are basically are connecting data sets across the globe, basically internet data, and training this model, right? All of this internet data is very generic, as we discussed, right? It has a very general knowledge. Specialized models means we need to get this data sets from people who are like, skilled people, or like, enterprises and smaller companies which have like very special data set. We would love to have them connect and provide these data sets. When they do that, right, the best way to enable that to happen is to incentivize them. And the second thing is to make sure that you give them confidence that they can trust the system, right? How do you give that confidence? You provide them with a protocol or something which is a general ledger where you can go and watch how your data is being stored. You can see that you have ownership to your data. Your data is pegged to your wallet. And when a model gets trained, if your data sets is used, you can visibly see which model is consuming your data set. It's on chain, it's traceable on chain. And when this model gets used, you can see whether your data was useful in that model's output. And you could also look at like what was the payment that came into that particular model. So we have it all on chain, right? Someone contributes data, it goes on chain, so you can see the ownership. The data gets used by a model developer, that is traced on chain as well. And when the model gets launched, if the model is used, every time a model throws an output, we show whether a data set, let's say 300 that was shared, that 300th data set, you can see whether that was causing any influence of that model, right? And that output. If your data set has caused an impact on that output of a model, we attribute and showcase how much of your data set was impact, like what was the impact that was created. Let's say out of the inference you had like 30%, 40% of your data set to be providing impact and like providing the solution, then you get rewarded accordingly. Again, this is on chain. The model developer decides how much of his revenue he wants to share with the data contributor. He shows that on chain. That's how he runs his contract. And then you can see it on chain on how much impact that you've created and how much of the revenue you're going to get shared for. And you can trace it back and see that you're getting paid. You'll be able to see this entirely on chain. You'll be able to see the entire provenance on chain. So that is what we are trying to solve, and that's the proof of attribution protocol, where we attribute to data that was being contributed by a contributor to a model, and then we show it on chain so they can verify and they can basically get to know why they're getting paid. That enables them the trust to contribute more and more. If you take a look at it, right, the reason why we, let's say we do podcasts and like, we upload videos to YouTube and all that, there is some sort of monetization, right? People get rewarded, get paid and they're following a passion. They want to do it more because they're getting recognized. Very similarly, we want to enable data contributors to get recognized and get paid for it. But in a platform like YouTube, the biggest issue over there is not open. It's a centralized system. You need to believe whatever they pay, right? You might be creating a much bigger impact. You might be having much larger views. You might be having much more reward than they actually pay for you. But you accept that because, that's the norm and that's the largest player out there. It's centralized. They've taken the market. So there is no other option to fight back, right? AI could soon become that, right? All the AI model companies can just go ahead and collect your data set and never reward you or pay very minimal rewards if they are pushed to do that. And we all have to accept that. There could be potential ways to solve that if you do it at the initial stages and if you can actually capture a good market out of this. That is what OpenLedger is trying to solve. We want to make sure that this is going to become a problem later on. There is going to be a lot of needs later on, as soon almost started. So we're building a platform where people can contribute data, monetize it, and they can know visibly how much of the data is useful, and they can see it on chain. It's transparent and it's traceable, and so that this is a much more open system than something like Hugging Face, which is a closed and not a monetizable system there. We want to change that, and that's what we're trying to do.
That also seems to plug into a little bit of
Hey guys, this is Ram. I'm one of the core contributors at OpenLedger. OpenLedger is a blockchain for AI. We enable users to contribute datasets and build AI models and have apps use these AI models and pass on reward back to the data contributors. Our idea is to enable anyone who contributes datasets to building an AI model get rewarded for the contributions that they do. Typically, internet models that you see today, larger language models like OpenAI, Llama, and all that, use your data that has been consumed from the internet, and you don't get rewarded for that. But the idea behind this is that AI is not only just there, it's going to evolve more than that. AI is going to be much more specialized, and the data is among the people, enterprises, and businesses. We want to make sure all of them get rewarded as part of this process. And thanks a lot for having me here. I'm glad to be here and talk more about OpenLedger.
all that notion around black box, explainable AI, and all these things. Like how do you see that from an enterprise perspective, right? Because oftentimes that's a huge criticism people had or still have towards AI models, that you basically don't know how it came to that output, how it came to that conclusion, right? And thinking is kind of a progression here, but it also is an output, right? So you don't
Yeah.
really know.
Yeah. So if you take a look at all these models today, right, they're not explainable. You don't know how they're working because there is no clarity on what kind of data sets is being used. Like even if you take a look at an open source model like Llama, there's no visibility on major of these models that they announced. There's no visibility on what kind of data sets that they used. So if Llama model is used by an enterprise to make its decision, let's say by a hospital or an e-commerce company, or let's say a lab is going to use that, there is no explainability in that. There is you can't, if you want to get you got an answer and you've implemented that as part of your business, you can go back and see which data caused that answer by the AI and why you used it, right? That is what we would like to change using specialized models. And at least on specialized models, we know what data set is being contributed, even though we don't know what's happening on the base model. What we're trying to figure out is that as part of the attribution, the byproduct of this, or what happens out of this is that every time attribution happens, we're able to reward people. We also figure out what data is causing the output to come, right? So through that, we are making the model much more extendable through data. Every time an output comes in, you'll be able to go back and see what data set caused this output. And using that, you can get more of the data if the output was good, or if the output is bad, you feel it's malicious and the AI is compromised, then you can go ahead and remove those data, which can be like potentially poisonous data sets. So through that, we would love to explain how an AI works using data, right? And enterprises need that. Like, for example, we work with a large e-commerce company, which is using their internal data sets to build a model with us. And one thing they really wanted is to have an end-to-end trace. So, assuming they develop using this AI within their platform, and they manage their inventory based on this. They manage their SKUs based on this. Then in the end of the day, your audit, right? They would want to go back and see what are the decisions they made and why they made that. And it's going to be relied on an AI. They want to make sure that they have an end-to-end trace on what data was fed, how it is processed by the AI, and what was the output and what really impact it created, right? They want to have an end-to-end auditability of that. And that's why they want to work with us because we are able to provide them with this explainable model. You don't get that with ChatGPT. You don't get that with Llama, right? You put in a bunch of data sets, you get an answer. You have to trust that it's the right answer that is there, and you just have to use this. So that is what we would love to change using explainability, and that is important, right? You make a medical decision based on AI, and you diagnose someone. If you don't know why you're doing that, then that's risky, right? So everyone knows this. Very few people are working on that, and we are one of them.
It also sounds like that, like explainability of AI also plugs into a little bit of the discussion of bias within AI models, right? That you're basically, when you actually can trace back the decision or the outputs of a model, you actually should also be able to, like when you identify bias, that you also trace back which data set or which bias in which specialized data set actually caused that. Is
Yeah,
that
yeah,
also something you work on, or is that just a
yeah.
byproduct?
Again, that's part of the explainability, right? So when we provide data like these models to people and they're able to use a blockchain to trace and figure out like how data is influencing, then if there are two ways this they see biases. If they want to remove the biases, they can. In certain cases, you might need more biases, right? Let's say you're building a specialized model only for America, right? And it's about healthcare. You would want very biased data set of people, majority of races that is living in America, right? So in that case, you would need biases to be fed into the model. And let's say it's a general model, and biases should not be there. It should be fair, and it should not have any kind of orientation to a particular race or a subject or a matter. Then you can use explainability to remove those orientations. So again, it's again a product that can be that's a byproduct or sort of like what are the use cases that can be done using explainability. Removing biases is one of the biggest use cases. One way that we're trying to figure out this is that like first we are working more on specialized model layer, right? On the specialized model, we're now figuring out how data is impacting the output. Next, we want to go much more context driven, right? You know, data, you know, the output that comes in. We want to figure out the context the AI model derives out of this because you would have learned something in your life, right? I would have learned pretty much the same thing in my life. But what we derive and tell out of that is two different things. Your context of the world is different, my context of the world is different. Similarly with AI as well, right? An AI model has different contexts based on what's been fed to it and how it kind of understands, let's say, what has been fed to it. Getting to know that context is very important, right? Let's say we ask about who is Alexander, right? It will tell you who is Alexander, but actually the way it tells, right? Alexander is a king who's known for his, his strength, and he's known for his courageousness and how he fought all these years and stuff like that. When it tells that, it's because it read about various rulers and various kings and stuff like that, and that's how it's able to actually get a context and give you an answer, right? So understanding that context is also very important to actually know how an AI model works and how it actually gives you an answer. So that's very important. That's sort of like the next steps on what we do. So there is a lot more depth into explainability and how data is impacting a model. You just barely scratched the surface here.
Lloyd, cool. I mean, the whole purpose of this podcast is to scratch the surface, right? To make it
Yeah.
more accessible to people.
Yeah.
Um, but maybe let's go one layer below the surface. From a technical perspective, um, attributing data sets, like how the output is being derived. Like usually from a technical standpoint, you have these layers within your AI model. You have weights and that's basically how an output is derived, right? It's a probabilistic model most of the time, right? At least for my uh, basic knowledge here.
Yeah.
And like, is it from a technical perspective, you just feed a technical knowledge, also specialized knowledge, in real time when a query is being made, like within that context? Or is it actually something that you train your weights on? Like, how does that
Yeah.
work?
That's a that's a good question. There are two ways to do this, right? Usually, when people want to customize a model they don't need to their own requirements or specialize it, there are multiple ways you can do. Best two ways to do is to provide like a RAG or fine tune the model. Typically, people go with RAG. They provide like context where RAG is more on like giving a better prompt. You provide like a additional data sets and you ask a question, and then it goes and uses your data set that you added as a RAG, and then it gives you an answer. Now it has a context of what you're asking for. That's the probably the best way to go forward, and that's I mean, not a I wouldn't say best way, but like the quickest way to go forward, right? So we provide RAG solutions as well. So not only like model fine tuning, not just enabling people to build specialized models, all the data sets as being contributed to OpenLedger, they can be used as a RAG as well. So that's the first layer. You contribute data set, it can be just used raw as a RAG. Next, if that doesn't solve the purpose, what you do is basically you fine tune the model. You take the data sets, you train it, superimpose the data set into a model where you post train the model with more data set, and then you make a specialized model. Now you have a fine tuned version of the model with more data, which can be used to get your answer. So these are the two ways that we try to approach this. I think this has been the most successful ways that we've seen, and most of the people who have been building in our testnet have tried both of them, and based on the need and case, they try to change.
Hmm. I mean, I definitely can see like how you attribute, uh, also how you trace back, like which data sets have been used using RAGs, right? But how does that work if they actually fine tune a model?
Yeah, so RAG is simple as you know that. So someone provides additional data, you can go back and trace it. Uh, how kind of like on fine tuning layer, right? That's the biggest challenge. And how did we solve is based on this paper. We've announced about this before, and we're going to announce it in a white paper as well. We built this based on a paper called Data Inf. So what it does is basically it figures out the influence of a data in a fine-tuned model, right? So what we do is like we kind of use data's like basically loss function. We remove all the data sets and figure out which data had the biggest loss. It means that it was the biggest impact creating data set, right? Um, like basically like you give an answer and what if I reverse engineer this and remove all of your knowledge and how much of your answer goes bad, the biggest knowledge that I remove, the biggest impact it could have created in your answer, right? So out like which data had the biggest impact on the loss, and then that is what the data we attribute and showcase. There's much more like details into it, much more technical related details, which you can see it on the white paper on how we do it. The biggest challenge that we had was that it took us almost like for one inference, it took us more than like 15, 20 minutes on an average time to figure out, right? We had to bring it down to like a couple of seconds. That's what we worked on in the last year or so. Because think of the compute cost it would cost us if we actually do it for every inference, it would cost like 15, 20 minutes, right? So we had to bring that down, and that's the work that we did over the last 1 year, majorly on the attribution side.
Okay, that's very interesting. I got two questions. I hope I don't lose them. Um, what the first question is, so it's basically it's kind of brute force approach, right? You pull away one data set, you see what's the loss, and so on, and you peel the onion, basically,
Yeah,
right? From my
yeah,
understanding. Um, like I can see, like even if it's just a few seconds, right? On one hand, it's definitely, I guess, expensive if you do that on a regular basis. So it might need to be, I guess, on demand. But like how does that work if you have, let's say, 50 specialized data sets contributing to that?
Yeah. Yeah. So what we do is that we batch this, right? We don't do it on real time because if I'm going to reward people, I don't have to pay you like every second, right? You don't mind getting paid every like let's say a day or two. So the best way to do this is to batch all the inferences together and then figure out how the attribution happened. So that's what we've done. We've basically optimized. We don't need speed in this. We just need accuracy. Um, but accuracy over a varied point of contact, right? So that's what we've done. We don't do it at real time. We do it at batch stages. So the GP cost that we use is much more lower. Not like how in real time I ask a question and you need quick inference, right? So over there you need to have like very highly scaled up CPUs. In this case, it's much lower, much simpler, and we have very optimized way of how we have done that, and all that is part of the research that went through. So yes, so since
Interesting.
it's batch, the cost is much lower.
Cool. And from an architectural point of view, I like one thought I just had, and that could be a little bit naive, right? But I guess these technical models, that also these specialized models are not highly dynamic, right? Like once you have a specialized model set up, you usually don't change it much. So why not having some kind of a validity proof or something like that, where you're basically doing the training, like maybe bringing, I guess, training on chain, like I guess where my thoughts are going, right? That you basically
Yeah.
can get that before and you save the costs afterwards. Like, what are your why doesn't that
So
work for?
you mean on the attribution or on
Yeah.
the on just so okay. So this is the thing, right? So when you ask a question, we wouldn't know what kind of question you're asking
Ah,
because
okay,
every
now I get.
inference is very unique, right?
Okay.
So based on that, we will not be able to figure out before. We need to do it in post the inference time.
Okay, and so also from a MVP, I know you're not in the MVP stage, right? But
Yeah.
one could also, in some sense, solve this, I guess. Maybe it's not as accurate, right, which is a
Hmm.
big value proposition, of course. But one could also say, okay, these are the data sets, and they have that importance, like general importance rates in that specialized model. So it would be
So yes,
independent of
we
the
they
query.
could like for example, let's say we are building a model for healthcare. Um, we could have certain data sets that is the most common questions that are asked in these data sets are impactful. And I think yes, we could figure that out, but that's not very. But even though we figure it out, it's not going to be fair if we reward them beforehand because everyone is contributing data set. Um, Maybe they're prioritized better, right? That again, we leave this to the onus of the model creator, right? We are an infrastructure platform where we provide the solution. Model developers use our platform to correct data sets, and then they would decide how they want to reward the data contributors. If they want to reward these data contributors beforehand, we have mechanisms for that as well. Like they could figure out like I would need these data sets, and if someone who provides them the first, I'm going to reward them, let's say, potentially a percentage of the revenue I'm going to make out of this model, right? And beforehand or something like that. They could do that, but it's up to them. We don't encourage that, but it's up to them. But typically, what really happens is that people collect data sets, and these data sets are like they tell what kind of data set they need. Most of it is the most important data set that's needed, and they collect them. Some of them might not be so useful, but they still collect them because they need to have the entire context. Model gets trained. Only when it gets used, they really actually figure out what is the market is looking for, what are the queries that is being asked, and then they try to reward people accordingly. So, like for example, we all would ask ChatGPT about, let's say, holiday plans, and most of the common questions has been like holiday plans, right? I read somewhere. So that could be the most useful data set in the last year or so that ChatGPT was trained on. But doesn't mean that that's going to be the same, right? People will evolve from there. People will go much more. They will ask questions that are much more relevant as they start to use ChatGPT. So it wouldn't be fair to actually reward people based on what they think is the most important data. It should be fair as people use these models, then they reward the data contributors. That's where the fairness comes in.
Love it. Super interesting. Thanks for sharing
Yeah.
that.
Yeah.
Well, then I would say, are there maybe three key takeaways or three things you want people to remember from this core session, or maybe even three call to actions like checking out your blockchain and like whatever. What should
Yeah.
they do?
So important aspect I would love to say is that I think we all should be aware that AI will be creating a big impact. All our lives. I think the previous generation to us and us also, we choose convenience over privacy, right? Like we didn't mind like larger corporations taking our data and like using it for various use cases. That's evolved over AI right now, but at least in AI, we have a choice to make where we can still own our data and we can decide what you want to do with that, right? We can create our own AI. Like we can basically um, be a part of the AI era that's about to happen. So people need to become much more aware. People need to become much more knowledgeable on how their data is useful. So that's one thing that I would love to tell people, and also learn about AI, right? Because it's all going to change our life. And then we are still in the stages of development right now. We are in testnet. We are going mainnet soon. We would love to have feedback from the community. We always encourage that. We've gone and built this out over the last 1.5 years by constant conversations with the AI community, talking to developers, talking to builders. We would love to have the users across the globe also to provide feedback on the product as well. That'll help us build a better product. So that's two most important things. And third is like go check out OpenLedger HQ. We have people, as I told you, like building on us. We are going mainnet soon, and we already have like 10 plus projects building, including a team which is from Google DeepMind, who decided not to use any traditional AI companies. They wanted to work with us. We work with a lot of enterprises, a large e-commerce company, one of the largest ones. We work with them. We'll be revealing about it soon. We work with the government, sovereign government based in the Middle East. We are building a model with them. We'll be announcing about that as well. So these are people who are trusting us. So we'd love to have you guys check that out as those news come and keep supporting.
Super exciting. Well, thank you for your time. It was really a pleasure
Thanks,
talking
man.
with you. Learned a lot. Pretty sure the
Yeah,
audience as well. And yeah, all the best with
awesome.
OpenLedger.
Thanks, Kevin. It was nice talking to you.
Likewise. A good one.
See you, man.
WaveAct, the web-free software company that understands what you want.